Good morning, ladies and gentlemen, and welcome back to the MBS Bite Size Theatre here at the Reba Village. I'd like to welcome Stefan Mordew to the stage, and he's going to be presenting on BIM and Health and Safety. Welcome, Stefan.
Okay, thank you very much, Paul. Thank you very much for attending today. So what I would like to talk about today is BIM and Health and Safety. It's something that the two really aren't said hand in hand at the moment, but I think it's an area we should really start to look at. So if we just have a look at the case for BIM, why it came about. We had the government construction strategy. It's been out over a year now. And basically the government looked at a number of ways that they could save 20% on government procured buildings. They looked at soft landings, they looked at methods of procurement, and one of those things that they highlighted was BIM, Building Information Modeling. So we see all the benefits of BIM branded around, greater predictability, we talked about cost savings, it's going to deliver us faster buildings, etc., etc. But what I'm really interested in is how can BIM help us reduce fatalities on site? How can it lead to reduced accidents? And essentially, how can it provide us with a safer asset? So what I'm showing here on the left, this was taken from the investment report from the BIM task group. So down here, you've got the RIBA stages of work. The red line is showing the measured benefit of BIM, and the green line there is showing the upside potential. So essentially, what we're saying is towards the end of the life cycle is where the biggest benefits of BIM is going to be. This is also where perhaps the biggest health and safety risks are going to occur, right towards that end. And if you look at the government documents, there's really not much mention of health and safety at all. It's mentioned a couple of times. And at the minute, we haven't really got any tangible data from the government exemplar projects going through. So it'd be really good very shortly to get a handle on those and to get some real statistics. So I just really want to talk about the hard facts. So what we're looking at the top one here is 20-year trends in worker fatalities. The blue line representing construction. So if we go back to 1990, we're up to 120 fatalities. It's terrible. It's slowly gone down. It's dipped down. 2008, 2009, it's gone down. I suspect that may be to do with recession and perhaps a decline in the amount of construction going on. So the bottom, we have a closer look from 2005. Again, you can see a steady decline, but then it's going back up 2010, 2011. So we had 49 fatalities in 2009 and 2012. 28% of these were in the construction industry. So when we take into consideration manufacturing, agriculture, etc. So it accounts for the greatest number of fatalities of injuries in all industry sectors. So there's a number of challenges that have been facing health and safety recently. There's a lot of red tape. We had the Young report, followed by the Lufstead report. There's talks of a new CDM regulations 2014 coming out. There's a National Occupation Standard, a BIM standard, which is currently out for review. So there's a lot to think about, but then we've also got this new digital construction, which is coming to the forefront. So how can this digital construction really help us? If, like me, I don't know if anybody a sort of child of the 80s, I loved films such as RoboCop and all these fantasy films. And back as early as perhaps 1984, we saw The Terminator with the augmented reality, Star Trek. So we were really talking about technologies which were very, very futuristic. And, maybe are these just Hollywood fantasies? Well, I would say that technology is here today. This is the CEO of Google. You may have seen him in the press recently with these Google glasses. And it's using the power of the internet to, by looking through the glasses, you can connect up using GPS and you can see a whole host of things. So how can we use that technology to harness health and safety, improvements in health and safety? And we often think about these technologies, but not always in a construction context. So if we just think about the general worker on site, there'll be an awful lot of information attached to this particular person. So I can imagine looking through these Google glasses and being able to see when this guy last had his toolbox talk. You know, is he a first aider? When will his hard hat need replacing? And again, this is all technology which is here today, but we don't always think about it in a construction context. So there's a number of ways that BIM is really helping health and safety. One is model checkers and automation. So using a number of software, that, for example, this is Celebri, we can take a model in an IFC format and we can begin to check certain things in there. We can begin to do walkthroughs, we can begin to test it, validate it. And what it allows us to visualize hazards early. And if we visualize them early, we can eliminate them. We can produce non-compliance reports. And this sort of technology is already used in America for compliance with the disability requirements. But one thing I would stress, with all this technology, it still requires a human intervention. These are what we call a rule-based system. So you set up a number of rules, but it still needs human intervention to actually analyze those rule sets. So we also have 4D modeling, so we can begin to prototype things before we actually go into manufacture. We can use it to simulate safety netting. We can also begin to look at sequencing. How do we deconstruct a wall, for example? And we can all do this in the safety of a virtual environment. So there's going to be no hazards and no risk. And this is an example where they use modeling to look at a crane collapse. You know, what would happen if that crane unfortunately went down? How far-reaching would that be on the site? And that's particularly important. You know, recently we had an incident in the town where a helicopter hit a crane, unfortunately. So, but we can begin to model what impact this would have. So if we look at the actual BIM objects, how can they help us? Well, when we think about BIM objects, we can think about the actual physical representation of that object. We can begin to think about how we manipulate them. But what's also interesting is we can begin to add more data, for example, clearance zones. And this comes really important if we're talking about plant. How much room would we need to actually access that plant? So, you know, we can really start to harness BIM objects. I just want to talk about the main causes here. So I'm looking at worker fatalities. 47% of fatalities were caused by falls. And if we look at the most common causes of major injury, 15% were by being struck by moving or falling objects. So a lot of these health and safety risks are actually on site, on the construction site. So just thinking about the fall protection here, this was a nice little example using Tekla, using an automated system where by setting up a rule-based system, it would detect certain holes and apertures in the slab, and it would appropriately put a railing system. And you can quickly begin to take a quantity takeoff, you could update the schedules, and also you're beginning to get a nice little visualization from that. And we tend to think about clash detection. The typical shots that we see of clash detection is the yellow magenta pipe going through a green pipe. But how about clash detection on site? How about clash detection from site worker and machine plant, for example? So this was a nice trial using a real-time mobile resource locating tracking device. And the workers had a small GPS device in the hard hat. And there was also a transmitter in large plant. So by setting up proximity zones, you would start to hear an audible alarm going off. Again, we can start to look at simulation. We think, again, clash detection in terms of mechanical plant, but what about clash detection in terms of distribution of materials on site? We can start to track vehicle movement on site, where's the traffic coming from, etc. We can then use it to check clearance and what's the best route to actually deliver materials. So just looking at the crane, this was a nice little example where by adding a small antenna on the end of the crane hook, you could start to simulate the movement of that crane. And then so you can really look at safe zones around site and areas to avoid. So above all, what I would say is, let's keep information simple. A simple idea is to get information to the site porter cabin from the BIM, and this can be simple as screenshots from a model. It can be about hotspots, areas to avoid. And if you think about the people that are on site, there's probably likely to be many languages being spoken. So a clear visual representation of risks is, I think, can really, really be valuable. So I just want to leave you with one final thought. This is David Phelps, I believe he's here today. We've talked about technology here today and how it can really, really help. And that's just one part of the equation. And what Dave said, the biggest danger is that we get bogged down in a technical discussion. So we always have to remember that with BIM, it's a behavioural change more than anything else.